All right. Hey, everyone, and welcome. Today, we're going to take our Docker skills and kick them up a notch. We're moving past just getting a container to run on our machine. We're diving deep into what it really takes to make it production ready. You know, secure, efficient, and super resilient. Let's get into it.
And this is the big question, isn't it? I mean, that feeling when you first type Docker run and your app just works, it's awesome. But production, that's a completely different beast. It demands a lot more than just running. It demands true robustness.
And you know where it all starts? Right at the very beginning, with the blueprint for your image, the Dockerfile. Because how you build that image is absolutely crucial for performance, for security, for everything that comes later. Okay, check this out. What's so cool here is how a tiny change in the order of things makes a huge difference. On the left, we do what a lot of us do at first. Copy everything in, then run npm install. But on the right, look, we only copy the package.json files first, run our install, and then we copy the rest of our code. So what's the big deal? Why does this one little change matter so much?
It's all about the magic of layer caching. See, Docker builds images in these layers, one on top of the other. And if nothing in a layer has changed since the last build, Docker just reuses the one it already has, the cached version. Now think about it. Your source code changes constantly, right? But your dependencies in package.json, they change way less often. So by isolating that long, slow npm install step into its own layer, we cache it, and our builds suddenly become lightning fast.
All right, sticking with that theme of efficiency, let's talk about a real game changer, multi-stage builds. This is all about shedding weight. It's about getting rid of all the junk your application doesn't strictly need to run in a production environment.
So here's the big idea, right? You use a big, chunky image that's got all your tools, your compilers, your build libraries, the whole shebang. And you call that the build stage. You use it to create your final application artifact, like a compiled binary file. Then you start completely fresh in a new, super minimal stage. Sometimes it's from a scratch image, which is literally empty, and you copy only that final compiled thing over. All the bulky build tools, they get left behind. You're left with this super lean, super secure, tiny little image, perfect for production.
All right, our image is lean and mean. Awesome. Now let's switch gears and talk about running it as part of a bigger application, probably with Docker Compose, and specifically how we handle one of the most critical parts of any production system, secrets.
Okay, so this. Yeah, we've all seen this, maybe we've even done it, but it's a massive, massive security risk. Hard-coding your database password is an absolute no-go. And hey, even pulling them from a .env file directly into environment variables, it's better, for sure, but it's still got some serious problems. Let's really break down why this is so risky. Think about it. When a secret is just sitting there as an environment variable, any process inside that container can see it, not just your main app. They can accidentally get splashed into your logs during debugging, or worse, get exposed in a stack trace if your app throws an error. And this isn't just theory, by the way. This kind of thing has led to actual real-world data breaches. It's serious stuff. And when you look at it side by side like this, the winner is just crystal clear, isn't it? Docker's native secrets management, instead of just injecting secrets as plain text environment variables, Docker mounts them as read-only files in the special in-memory file system. Basically, they're locked down tight, providing way better isolation in a much, much smaller attack surface. So the real pro tip here, the thing you gotta do, is get your app to play along with this pattern. And the good news is, a lot of the big official images, like Postgres, they already do this. They're smart enough to look for a variable ending in _file. If they see it, they know to read the secret from the file path it points to. If not, they just fall back to the old environment variable. It's a really robust and secure way to do things. Okay, so our container is built smart and it's configured securely, but is it actually okay? Is it healthy? Just because a container is in the running state doesn't mean the application inside is actually working. We need to plan for resilience.
And that's where this awesome built-in feature, the health check, comes into play. It's a simple but really powerful tool. It's basically Docker's way of knocking on the container's door every so often and asking, "Hey, you good in there?" by running a little command that you get to define.
And what can it catch? Oh, all sorts of common production nightmares. It can tell if your web server just gave up the ghost, if it suddenly can't talk to the database anymore, or even if it's struggling because of some bad configuration. And this is key because it allows your orchestrator, Kubernetes or Docker Swarm, to see that the container is unhealthy and actually do something about it, like automatically restart it.
And you know the best part? Setting one up can be ridiculously easy. Look at this example. All we're doing is adding one line to our Dockerfile. We're just telling it to use curl to poke a local URL. If curl is happy and gets a good response, the command exits with a code of 0. That means I'm healthy. If it's not happy, if the server is down or returns an error, it exits with a 1, which means, Houston, we have a problem. Simple, but so effective.
All right, we're in the home stretch. Let's nail down a few final but super important details to make sure our containers are stable, predictable, and just, well, behaved citizens in a shared production environment.
Okay, let's talk about data. Where does it live? Buy mounts are awesome for development, right? You link a folder on your machine directly into the container. Super easy for editing code. But in production, you really want to be using named volumes. Why? Because Docker is in charge of them. They're not tied to some random path on the host machine, which makes your setup portable, and they give you much better isolation and control.
Okay, and this is a huge one. Please listen to this. If you don't set resource limits, you're creating a ticking time bomb. One container with a memory leak can just start eating up all the host's memory until there's nothing left. And when that happens, the Linux kernel basically panics and activates the out-of-memory killer, which starts shooting processes to save the system. And it might not just shoot your container, it could take down the whole Docker engine or other critical services.
So, the solution is simple. Be a good neighbor. Put your container in a sandbox. Use these flags, like -memory and -CPUs, to tell it, hey, you can have this much memory and this much CPU, and that's it. That way, if it does go haywire, it just hits its own ceiling and doesn't take everybody else down with it. It's essential for a stable system.
And that really brings us full circle. Moving from a dev container to a production-ready one means thinking about all these things: efficiency, security, health, and stability. It's about building software that doesn't just work, but is professional and truly dependable. So as we wrap up, I want you to think about your own containers. Are they just running, or are they truly built to last? The real question is, what's the first thing you're going to go fix? Thanks for joining me.